This video is over lesson 43, simplifying rational expressions, and is for my Algebra 1 class. So remember that rational expressions, when we hear the word rational in mathematics, we should be thinking back to rational numbers. So rational numbers are numbers that can be written as a fraction where the numerator and the denominator are both integers, but the denominator cannot be 0, because if the denominator is 0, this would be undefined. And so we have to exclude any value that would cause the denominator to be 0. So moving forward in the book, there are going to be times when you're asked for when is this rational expression undefined, and there are going to be times where you're asked for when is this rational, or what are the excluded values of this rational expression. And those two things are very related. So this expression right here would be undefined whenever the denominator, 4x, equals 0. That's when it's going to be undefined. So if we do some quick solving there, divide both sides by 4, and therefore whenever x equals 0, then we know that it's undefined. Whereas, as we've learned, the excluded values, we have to exclude the possibility of 4x equaling 0. So 4x cannot equal 0. Because if it did equal 0, it would be undefined. And so again, some quick solving here. We can divide both sides by 4. X therefore cannot equal 0. So the big difference here, and there's really not a big difference, but the big difference here is just a matter of what are we talking about. So if we're asking for when is it undefined, it's undefined when x equals what? Versus what are we excluding? What can x not equal? Okay, so undefined when an x equals what? Excluded values though are what can x not equal? So if we take a look at the next one here, x minus 4, when that equals 0, this would be undefined. So simply add 4 to both sides, and we see that this will be undefined when x equals 4. Versus what would be my excluded values? Well, I have to exclude the possibility that x minus 4 equals 0. So x minus 4 cannot equal 0, and it solves the exact same way. Add 4 to both sides, and x therefore cannot equal 4. X cannot equal 4 because when it does equal 4, it's undefined. Which brings us to our third example here in this chart. So in this case, 3x squared minus 2x equals 0 would make this undefined. And we're going to do like we've done in previous lessons, and we're going to go ahead and factor this to help us solve. So if we factor an x out of both of those terms, we're left with a 3x minus 2 equals 0. And then from here, we're going to go ahead and split this, because remember, if a times b equals 0, then either a equals 0 or b equals 0. So I can split this, so either x equals 0 or 3x minus 2 equals 0. Now that's simple enough to solve, and I'm kind of running out of room here, so I'm going to cheat a little bit just because this is notes. And if we were to go ahead and solve this, we add 2 to both sides and divide both sides by 3, we're going to end up with x equal to 2/3. So there's actually 2 times that this is undefined. This is undefined when x equals 0, and it's undefined when x equals 2/3. Okay. Whereas we would say, what values then are we going to exclude? That's just the not equal to. So if we're excluding it, it cannot equal 0. And again, this solves the same way. The only difference here is our little if statement. If a times b cannot equal 0, it does change this just slightly. Oops, I just realized I made a the instead of then. There we go. Then a cannot equal 0. This becomes an and. B cannot equal 0. So the only difference between the two is instead of an or, we have an and. So in order to make this 0, it just needs to be one or the other of those. But in order to make this an and, or make this not equal to, it has to be an and. Neither one can be true. So if I split this then, so x cannot equal 0 and 3x minus 2 cannot equal 0. Again, add 2 to both sides, divide both sides by 3, just for the sake of fitting in the chart. Therefore, x cannot equal 2/3. So once again, depending on what the book is asking for, read carefully. If it's asking for when is it undefined, it's undefined when the denominator equals 0. So what are we excluding? We're excluding the denominator equaling 0. So if we're excluding it, the denominator cannot be 0. So we're going to take a look at simplifying some expressions here. We've already done some work with this, so let's take a look again. In this case, I want to start with my excluded values. So looking at this denominator, x plus 4 cannot equal 0. So if we subtract 4 from both sides, x cannot equal a negative 4. All right, so since x cannot equal a negative 4, I'm going to go ahead, let's grab our green for that. I'm going to highlight that in green. So that's my excluded value. So remember, whatever's excluded at the beginning still needs to be excluded at the end. So either it needs to be excluded because it's still implied by the expression itself, or we need to explicitly state it. So in order to see if we can simplify this further, I'm going to factor both the top and the bottom as much as I can because of these plus signs. So we can't just reduce the 54 and the 4 because of the plus signs in between them. So I know that a 9 can go into both of those. So 9 goes into 54x 6x times, and then 9 goes into itself once. 4 plus x, there's nothing that I can factor out of both of those, so that's just done. Now, we're going to treat this denominator, since we weren't able to factor it, we're going to treat it like a quantity. We're going to treat it like there are parentheses around it. So up here, 6x plus 1 is a quantity, so again, we're treating that like one object. And then we have our 9. So I have one object, I have a second object, and I have a 9. Now, neither of these objects match each other, so they cannot reduce. And no, I cannot reduce the 6 and the 4 for the same reason. The plus signs get in the way of that. So you can only reduce before multiplying. You got a plus or minus in there, it messes that up. So really, there's nothing I can reduce here. There's nothing that's reducible. So if we consider here then, what excluded values do we have here at the end? Well, once again, x plus 4 cannot equal 0. Subtract 4 on both sides. I know we just did this, but still, for the sake of diligence. So this is our excluded value at the end. So is everything that was excluded at the beginning still excluded at the end? Yes, it is. Now this isn't really simplified. It is factored, but it's not really simplified. So, but we're going to go ahead and call that our answer and be done. So let's check the next one, see if we can simplify that. So before we do, I'm going to take the denominator, and I'm going to take a look and see if I have an excluded value. So 4x squared plus 6x cannot equal 0. All right, so now I'm going to factor that as much as I can. So I can pull a 2x out of that, which leaves behind, so 2x out of that will leave a 2x behind, and then 2x out of that will leave a 3 behind. Cannot equal 0. And I'm going to take advantage of that ability that we have to split this into its products, into its factors. So we know that 2 cannot equal 0, but remember that's good. That's always true. So we don't even have to worry about that. Write that one off. It's done. It's all set. No big deal. But we see here that x cannot equal 0. So I'm going to grab my green. That's going to be excluded value right there. And then the quantity, 2x plus 3, cannot equal 0. So some quick solving. Subtract 3 from both sides. 2x cannot equal a negative 3. And then divide both sides by 2. Therefore, x cannot equal a negative 3/2. And so, my paper slid, there's a second excluded value. So when I'm all done, both of those need to still be excluded, either implied by the expression or explicitly stated by us. So coming up here now to see if I can reduce this. So up top, I see that I can pull a 2x out of both of those terms. So when I pull a 2x out of a 2x squared, I'm left with an x. When I pull a 2x out of a 10x, I'm left with just 5. Down here, I see that I can also pull a 2x out of both of those. And when I pull a 2x out of a 4x squared, I'm left with another 2x. And then when I pull a 2x out of a 6x, I'm left with 3. So up top, we have a 2, we have an x, and we have a quantity. On bottom, we have a 2, we have an x, and we have a quantity. Now, these quantities do not match, so they cannot reduce at all. However, my 2x and my 2x can both reduce down to 1s. And so this will just be an x minus 5 over 2x plus 3. Looking at our reduced rational expression, I have 2x plus 3 cannot equal 0 here. So subtract 3, 2x cannot equal a negative 3, divide both sides by 2, x therefore cannot equal a negative 3 halves. So when we're all done, instead of having 2 excluded values, we just have 1. So since this one is still implied by the expression itself, we don't have to mention it. However, because this one is no longer implied, this is the one that we have to explicitly mention. All right, let's move on to the back. So on the back here, again, I'm going to take this and do this a little bit in a different order this time, but we're still going to do the same things. So this time, let's focus on reducing it first, and then we're going to go back and look at the excluded values. So in this case, I see that I can factor out a 2x out of both of those. So the first term will leave behind an x, the second term will leave behind a minus 7. And on bottom, I can factor out a 4 from both of those. And so that would be behind an x and a minus 7. So up top, we have a 2, an x, and a quantity. On bottom, we have a 4 and a quantity, but these two quantities match each other. So this time, because these quantities match, I can treat them like a single object and reduce them both down to just 1. They're gone. Now, looking at my numbers, I can reduce a 2 and a 4 down to a 1 and a 2. And then, well, the x is still just hanging out there, nothing to reduce with. So if I simplify this, 1 times x times 1 is just x. And on the bottom, 2 times 1 is 2. So this simplifies down to just x over 2. Now, looking at my excluded values, if I go back and I look at my excluded values, let's go back actually to the front here. I just realized I forgot something. So here's the thing. This was implied. So this is no longer implied, so it's got to be stated. So that all of our excluded values here are still excluded over here. They're either implied by the expression or they're explicitly stated. So sorry, I forgot that highlighting. All right, so back to the problem we were on. So let's look at the excluded values now. So 4x minus 28 would factor to be 4 times x minus 7, and these cannot equal 0. So 4 cannot equal 0, which check, that's always true. But then x minus 7 cannot equal 0. So therefore, add 7 to both sides. X cannot equal 7. So there's my excluded value. Now, in my simplified expression, we have 2 that cannot equal 0, but that's always true. So that's no big deal. That's not gonna cause anything to be excluded. So the trouble here is this x cannot equal 7 is missing. And since it's missing, it has to be explicitly stated. So this simplifies down to just x over 2. So if you had that, it would simplify down to just x over 2. So if you plug numbers in for x over here, it would be the same as plugging in numbers for x over here, with one exception. If you tried to plug in 7 for x, you'd get undefined. And so we have to say that over here that you can't have 7 for x. And then our last example here. So again, I'm going to do this one. I'm going to focus on the reducing first, and then I'm going to go back and look at the excluded values, because the order there doesn't really matter as long as you do it all. Here, given the decimals, and if I ignore the decimals, this looks like a 35, this looks like a 7. So you know what, I'm going to factor out a 0.7 here. So if I factor out 0.7 and then a t, right, because we got a t and we got a t squared, so 0.7 t. So if I factor out 0.7 from that, so 0.7 times what is 3.5? Well, 5. Now if we factor out the t, there'll be no t left. And then for this other one, factor out a 0.7 from 0.7, well, that's going to leave behind a 1. But then factor out a t from t squared, you're going to be left with 1t, or just t. You can double check that by distributing that back in to make sure it goes back to the original, and it does. And then down here we have 1.4 t squared, which I would probably just leave alone. Looking to see if I can reduce anything, 0.7 and 1.4 can reduce. If we divide them both by 0.7, this is one group of 0.7, this is two groups of 0.7. And then my t will reduce with my t squared. T will become another 1, but t squared will become just a plain old t. And then up top we have the quantity, but no other quantity to match it. So cleaning this up, simplifying it, 1 times the quantity will just be the quantity, 5 plus t. And on bottom we have 2t. Now remember, you cannot reduce those t's because that plus sign is going to mess it up. We can only reduce before multiplying. If you have addition or subtraction in there, it's going to throw that out. That's not an option as a skill. So now if I look at my excluded values, 1.4 t squared cannot equal 0. So this means that 1.4 cannot equal 0, which is fine. It never does. This also means that t squared cannot equal 0, which of course just means that it's a double t cannot equal 0. So t cannot equal 0 and t cannot equal 0. So really there's only one excluded value here. T cannot equal 0. Over here, red pen, over here, 2t cannot equal 0. So we know that 2 will never equal 0. That's always true, no big deal. But then t cannot equal 0. And so in this case, every value that was excluded at the beginning is still excluded at the end. And so therefore, there is nothing that I need to add to this answer. I can just leave it as it is. And that, ladies and gentlemen, is the end of our lesson.